Hi, welcome to a new release of Arduino CLI, our command line interface for all things Arduino coding. I'm Ubi Defeo with the Arduino tooling team. We're a small team that works on two projects, which are the CLI and the Future IDE. We're very happy to bring you the changes that we've been introducing over the past few weeks. All these changes come from interaction with our community. So if you want to participate in this project, go to our GitHub repo, which you will find down there, and talk to us. Bring issues, tell us what you like, what you don't like, and many of these suggestions are very valuable. So we invite more and more users to contribute to this project. It's open source, that's the goal of it. So today we're going to go through a tutorial style rundown of all the new features and new commands and flags and options that we've been bringing to the CLI. And we're going to do it with an overhead camera up there and a project that I've set up in Sublime Text. So we're going to use Sublime Text, a few libraries, an overhead cam, an Arduino with a display and a button, and then we'll see how it goes. I hope you want to stay with us. One of the main changes that we've been bringing into the CLI has been how we generate configuration files and how configuration files are handled via the command line. So we're going to start from scratch. On this system there's practically nothing installed except the Arduino CLI. I'm currently using the nightly build, but this is basically what you're going to find in Arduino CLI 0.14.0. So if I run my command and help, if you've been using it a while back, you will notice quite a lot of new commands and options and flags. But basically what I want to do, I want to show if I have anything installed. So Arduino CLI, core list, and you will notice one thing. So the first thing that happened is that it automatically checked if there was something to download. So what it did, it went through the index files and it launched basically the update command. A while back we introduced this Arduino CLI update, which basically downloads the package index.json, the signature, and then the library JSON. So you have an up-to-date list of available libraries in our repository. And what's really nice is that right now my Arduino 15 folder has been created for me at first launch. So I can go in here and this is where basically everything that makes the Arduino CLI tick is in this folder. So what I want to do, I'm gonna go to my sketch folder and I'm gonna enter this LCD people counter example that I've been working on. And in here I have my INO file, I have a build folder which I want to remove, so I am now in my sketch folder. The only file that I have in here is my sketch. I want to use this sketch with a Nano 33 IoT because in the future, I plan on connecting this thing to the internet. So right now, as you can see, we only have an LCD and a button, and the LCD is connected over I2C. In order to use this I2C module, I need a library that supports it. And I don't know if I have it installed, but mainly I need to have support for the Arduino board that I'm using, and it's a Nano 33 IoT. And that board belongs to the platform Arduino SAMD. So let's look at our cores, what we have installed. Arduino CLI, core list. An empty result means that I have no platforms board support installed, right? So I need to find what files to install, what platforms to install in order to use my Arduino Nano 33 IoT. And how do I do this? The board is attached to my computer, which means that by running Arduino CLI board list, I'm going to be able to see what's connected to my computer. And I will see some Bluetooth devices, I might see my keyboard for instance, but it's also going to scan for every Arduino device that is attached to a serial port or any future different kinds of ports. And what you see here, it has recognized an Arduino Nano 33 IoT, which has this fully qualified board name, FQBN, and the core to install is Arduino SAMD. It is connected to this USB port, USB serial port. Well, this makes it easier for me. I can just install support for the board that I have, which means that by running Arduino CLI core install Arduino SAMD, let's try and be verbose about it, I can see everything that happens. I like verbosity in my terminal because I always know what's happening, and I know if it's, you know, some long download process rather than the terminal just being hung there. So it is installing all the files that it needs and all the tools that are required for compilation, upload, debugging when those are available, and so on. All right, there we have it. Arduino CLI core list is going to return this. We have several cores that we developed by ourselves, but because of how our platform is structured and documented, third-party core developers can develop support for their own custom hardware, boards, microcontrollers. The work that we did is basically documenting how to add support for your custom hardware into the Arduino ecosystem. Now SAMD is installed, which means that I can compile my sketch for a Nano 33 IoT. Arduino CLI, compile, the board that I want to use, so it's -B or --FQBN, Arduino, SAMD, and my board is Nano _33 IoT. And I want to be verbose about it. So this will give me some errors, and these errors will be generated by the fact that I don't have all the libraries that I need, right? The ones that have been included here, they're probably not available. And there we go. The first hiccup is here. Liquid Crystal I2C is the first library that the system looks for in order to compile the sketch. Let's use the Arduino CLI to look for the library that I need. And this is pretty simple. I can go Arduino CLI, lib search, and then I can search for a few things. Let's say liquid crystal and I2C. I have one hit, and this is exactly the library that I want to use. I want to install this library, so I will replace the command that I had up there with install. And I know this is the exact name of the library, and if I enclose it in quotes, it will install this specific library. And there we have it. So let me try and compile again. This is a library that I wrote, and I don't need to install it because I'm going to be using another library to manage buttons, so I will just go and comment it. And now it's looking for Ace Button. Ace Button is the button management library by Brian Parks, and it's a library that I recently started using, although I developed my own with the help of one of my colleagues. But this one is becoming pretty popular, and actually I want to give a shout out to Brian because he's using the CLI and he reports issues which are very helpful to us. And I invite everyone to report issues on our GitHub repo because this is how we make this product better. I need to install this library. Well, I don't want to use the library that is in the index. I can look for it and I will find it because it's part of the index. So let's look for it. Arduino CLI lib search Ace Button. Do you mean this? Yes, I did mean that. So let's go back here and let's correct the name. This is very helpful. And I found the library. I could easily install it, but I don't want to use the one that is part of our library repository. I want to use the bleeding edge version on his GitHub repo. And this is because maybe Brian has applied some patches which are not part of the release and are not indexed in our library index. Let's just say that I want to install something that is from a GitHub URL. And the problem is that before this new release, we had to manually download the repo and we had to put it in our libraries folder. But now we recently introduced this new feature, which is very powerful, and it allows us to directly install a library from a Git repo URL. But there's a caveat. We don't want users to accidentally download things that are not maybe working very well. We try to do a screening of the libraries that are submitted to our index. And you can install this, but you need a special parameter in your settings to allow what we call unsafe downloads. So let me try the feature and let's see if this is possible right now, if it's enabled. I can directly look into it. So let's look at the config file. Arduino CLI, config dump, and I don't have anything that tells me what I can download and what I cannot download. So if I go and I try to just download something from a Git repo, I can do Arduino CLI lib install git URL, and I want to use the URL from Brian Park's repo, so I can just copy the URL. And once the URL is copied into this, the CLI is going to try to install it if it is allowed to. And no, it isn't, because this flag is not recognized yet. Arduino CLI has some default configuration parameters which come from its internal workings. But in order to customize the way that it works, so for instance, where we keep our sketchbook, where we keep our libraries, and other configuration things that are related to the system, so the way that it behaves on your system, you need to generate a proper configuration file. So let's look at this. Arduino CLI config dump will basically tell you these are the basic parameters. This is the daemon port, these are the files, so the data is where my configuration data is, and I can go into this folder, and in there, when I create a new configuration file, I'm going to be able to find it. So let's look at this here. I don't have any configuration file. I have an inventory, I have a library index, the package index JSON, its signature, and the packages that I download, which are the cores and platforms. I have a temp folder and I have a staging folder. So let's not worry too much about this. Let's just say that we need a configuration file. Arduino CLI, config, and I can show the help. And the help is going to tell me that I can init and I can write the current configuration, which is the default one, for instance, into a configuration file. I can also choose where I want to store this file, for instance. And if I have multiple setups with multiple configurations, I can just generate a configuration file for every configuration that I want to use with my CLI. And that's very easy because I can use the config file as an input to have my CLI behave in a certain way. So let's just create a new one, Arduino CLI config init, and it has created it in the default folder, which is the data folder, which is the folder where we are now. And I can show it, and I can display the content of the file. And this is basically all the parameters that we saw before by running Arduino CLI config dump. These are the defaults, are now part of the configuration file that has been written to disk. So if I go and I edit this file, I can just change its behavior. I'm going to use Sublime Text config. So what I want to do, I want to enable installing libraries from Git URLs. To enable this feature, I need to edit this file. So it is related to libraries, which means I'm going to have a section that is called library. The parameter that I want to set as true or false is enable unsafe install. And we want to set it to true. Now, we call this unsafe installed not because you're going to end up downloading unsafe content, but because this is not part of our index, which means that none of us at Arduino has been looking into what's the content of these libraries. Be wary of the fact that you might download a library that possibly takes your Wi-Fi credentials without you knowing, and then you upload this firmware to your Arduino Wi-Fi and your credentials are uploaded to a remote server and you never know. So we really want you to be very careful with what you installed. We'll let you install this, of course, like we want our users to do everything that is possible in the command line, but of course, we want to retain a little bit of a safety measure there. That is, we give you the keys, you can turn them off. Once this is here, I'm going to be able to install a library from a Git URL, which wasn't the case before. Arduino CLI, config dump, and this is it. So from now on, I can install from remote Git URLs. Arduino CLI, lib install git URL, and I already have the URL in my clipboard. So there it is. And let's add a bit of verbosity to see what's going on behind the scenes. Now, this is funny because this says git URL and zip path flags are dangerous. Use it at your own risk. This, I just gave it away. You can install, as of this release, from zip archives. So if somebody gives you a library in a zip archive, or if you can download it from a website because somebody makes it available, you can just pass in this parameter and install a library that is contained into a zip file. Alright, so this is one more thing that we have in this release. Now let's get back to our sketch. I have already installed 2 libraries that I needed, right? This means that probably the sketch will just compile. So Arduino CLI, compile, -b, Arduino SAMD Nano 33 IoT. Let's be verbose about it. And wow, my sketch has compiled, which means that now I can upload it to my Nano using the -u flag, and I can pass in a port. And this should just work, uploading the sketch after it's compiled. Of course, it was already compiled and I would have been able to install it. And as you can see, the sketch has reloaded, and then I have howdy partners. And this means that, like, my sketch is working, the libraries have been installed. And let's look at something inside this folder, something that has changed over the past few weeks. If you remember using this CLI before, you would find a build folder in this specific location. And then we thought about it, thanks to the suggestion of a member of our team. He said, I often have my sketches as Git repositories. And when you have a Git repository, everything external that you don't want to be forced to upload needs to be manually added to a git ignore rule. So you have to basically go there. And the request was, I don't want the compiled files to be in this folder, because if I need to upload, I don't really need the artifacts to be in a local folder. So from a few nightly builds already, we create the files in the temporary folders, and when you restart your computer or when your temp folders are emptied, they're gone forever. And you don't have to worry about managing this. But we decided that it was very helpful to have a build folder that was custom defined. So what you can do now, you can choose where you want your files to be exported. So for instance, I can choose export binaries, and this export binaries is going to create our local build folder. Okay. So now, if I go list, I have my build folder, but even more, I can decide where this build folder is going to be, and now it's going to be named. So for instance, I can remove this build folder, and I can say, rather than export binaries, I can choose output dir, and I can put this folder anywhere on my system. I want to put it here, but I want to call the folder compiled firmware. And here, that is my folder compiled firmware. This is extremely helpful if you want to export the files to give to somebody else because you only need this person to upload the binary to the microcontroller using whatever mean that is not a bootloader, for instance. And it will relieve you from the craft that is added to your local folder. So what would be the point of compiling all the firmware into another folder? Let's first look into this. We have binaries, elf, hex, everything that is needed. The point is that we can target a specific folder in our system or on a remote drive and just compile the firmware there for another process to pick it up. So let's just assume that we remove this one, rm rf compiled firmware. Okay, that one is gone. And now let's compile the firmware to something else. Arduino CLI compile -b Arduino SAMD Nano 33 IoT. Output there. We can just specify a folder on our desktop, right? Desktop, my Arduino firmware. And now all the files will end up in that specific folder. So if I list the content of that folder that I just compiled to, my Arduino firmware, those are exactly the same files. They're in a custom folder which I decided to name in a specific way. Now what I can do, I can use the upload command from any other process. It could be another CLI running on another machine that has access to this shared folder, and I can upload it to my board. So let's see what happens. This is kind of a breaking change, because if your workflow relies on the fact that you have a default build folder in your sketch, you might wanna fix it. And we didn't completely take it off of your hands. What we did, we made it a default, because essentially the main goal is not to create any craft when you compile your sketch, stuff that you need to add to your .git ignore or that you need to manually delete every time. If the files are in a temp folder in your /tmp, or depending on whatever system you are, then the files are deleted at the restart and you don't add up any files on your system. Now, if you like the behavior of always having the build folder into your sketch folder and it doesn't bother any of your coworkers, we kept this as an optional parameter for the config file. So you can open your Arduino CLI config file or any config file that you are using, and you can add this parameter which is related to the sketch, and it's called always export binaries. And if you set it to true, you save this and then you try and compile again, it's going to create the build folder. And there it is. Everything that you need from this compilation that you can use with your programmer, debugger, anything, you can just find in this folder. I keep this one as a default because I like knowing where to find my files. Some more advanced users tend to use programmers or debuggers with our boards, and it's not intuitive how to figure out which programmer is supported by your board, especially because they are defined in the platforms. So we had a very cumbersome way of coming up with this. We were using a flag on the upload command to list the supported programmers. We decided that it was not the right place for this command to be, and we moved it into the board details command. So now, as you know, you have Arduino CLI board details, and you can pass in a board SAMD maker 1000, for instance, and you know exactly what the VIDs and PIDs are, the board version, and you know the supported tools and everything, as well as required tools. And now we have these extra lines, which are the supported programmers for the architecture. And we have eDBG, Atmel ICE, and SAM ICE. Now, depending on the developer of the platform support, you can have multiple programmers. You can have JLink or ST-Link or anything else. So if we want to see the programmers which are supported by our current board, we can go this way: Arduino CLI, board, details. We can pass in the board identifier, Arduino SUMD. We're working with the Nano 33 IoT, and we can do list programmers, and there you have it. These are the same details that came out from the board detail command, except everything else that we didn't need. We only want to know these supported programmers. So assuming that you are feeding these into a machine workflow, you can pass in JSON as a format, and it's going to give us all the board details. And from these board details, we can go and get only the programmer's key. If you use JQ or another JSON parsing system, that's the key that you want to pass into your workflow to get the right programmer that is supported. One very important addition in the flags that we added in this release is essentially a way to change the values in the configuration file. Now, not all the values, all the parameters are configurable. For instance, the daemon is not configurable because, we have consumers of this daemon gRPC protocol that need to connect to the daemon. So if this same process will be allowed to change the port, then another consumer might not be able to connect any longer. So right now, we allow adding additional URLs to this list, which basically allows you to add your own third-party developed platform implementation, which is something that makes Arduino as extensible as it is. We can also change some parameters, like I can definitely just change enable unsafe install. And let's see how we go about this. This is a new flag for the config command. Arduino CLI config H is going to show us add, delete, and set. These are the three subcommands which are available to the config command of the Arduino CLI. Let's try and set this particular one to true. You can see that there's a hierarchy in this. So enable unsafe install depends on library. So we can just say Arduino CLI config set library dot enable unsafe install true, and this has been changed to true. The same is valid for what we showed you, always export binaries. I can set it to false. So right now you can see that I had always export binaries set as true, so the build folder will be created. I can remove this folder and it's not there anymore. Arduino CLI config set sketch dot always export binaries. We'll set it to false. And now the time for Sublime Text to realize that this has changed, and it's set to false now. And if I want to add an additional URL, I would go Arduino CLI config add board manager dot additional URLs, and I will add my URL example.com slash Arduino custom board.json, and there we have it. If this were a valid URL, I would be able to just query this, but of course it isn't a valid URL, so when I will run Arduino CLI update, it will trigger an error because this package definition is not available. Of course, I can remove it as well. I can remove this URL. It has to be the same exact string, of course. When I go like this, and now if I run Arduino CLI update, it will only just go through our package index.json, and it will not fail because that URL is not there anymore. So that was definitely a lot to take in, but we had a lot of changes going between the last release and this current one. We wanted to share as much information as possible with you. We might be adding more features in the near future, but we're not going to promise anything here. Once again, thank you for staying with us. Thank you for tuning in. Keep following us. If you can, just subscribe to the channel and subscribe to our GitHub repo to have more information. Just keep your eyes peeled. Thank you so much from the Arduino tooling team. It's been great being with you. We hope to come back with more tutorials and more hands-on in the near future. Goodbye.